Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will see the last part of the exponential functions, which is part 5. Now the last problem, we have two functions f and g which are defined as follows. This is f, this is g, and they are defined on R. The first part asks to study the variations of g. This is g. Try to do it alone. Well, let's begin to study the variations. The domain is minus infinity plus infinity. It's already given. So we begin by finding the limit at negative infinity of this expression. And in this case, if we substitute, we get negative infinity times 0. So we use the reciprocal method. Ex minus 4 becomes in the denominator as e4 minus x. We use Hopital's rule. We derive the numerator as 1 and the denominator as minus e4 minus x, and we leave this negative 2 alone here. And by substitution, this would be 1 over infinity, which is 0. This fraction tends to 0, so the final answer is negative 2. Now, what is the limit at plus infinity of this expression? Just by substituting, we get this is plus infinity and this is plus infinity, so it will be plus infinity. Now, if we continue and we find the g prime of x, this is of the form mu times v, well, we get x plus 3 into e to the power x minus 4. Now, the table, e to the power x minus 4 is always positive, but x plus 3 could be negative, could be positive, and it vanishes at negative 3. This is negative 3. Now, the domain is from minus infinity to plus infinity. This is of degree 1, so begin with opposite, then same. This is opposite. This is same. And don't forget this 0. Minus means the function g decreases, and plus means it increases. Now we fill in the limits. The limit at negative infinity is negative 2, so we have to put a negative 2 here. And the limit at plus infinity is plus infinity, so we have to put a plus infinity there. And here we replace each x by negative 3 in the original equation for g of x. If we just replace it here, we get this quantity, which is minus 2.0009. So this is the study of variations of the function g. Now the second part asks to show that the equation g of x equals 0 has a unique root alpha, and to verify that alpha falls between 3 and 3.1. Remember, this is the intermediate value theorem. Try to do it alone and try to benefit from this table of variations. Well, on the interval negative infinity, negative 3, we can see that g of x can never be 0 because its maximum is negative 2. And when the maximum is negative 2, it can never be 0. And on the interval negative 3 plus infinity, we can see that g is continuous, g is strictly increasing, as you see, and the g of x changes signs. It changes signs from negative 2 point to plus infinity. So from these three conditions, we can tell that the equation g of x equals 0 has a unique root alpha. So alpha is a root that falls somewhere here. Now, how do we verify that alpha falls between 3 and 3.1? We have to find the g of 3, which is negative in this case, and the g of 3.1 is positive. Now, how do we find the g of 3 and the g of 3.1? We replace 3 and 3.1 in the original equation here. So from here we can tell that alpha is between 3 and 3.1. Now remember, dear students, when you have the intermediate value theorem, try always to benefit from this theorem by adding alpha to the table of variations. How? I just come here, I write alpha, and this is 0. So when x is alpha, I can state that g of x is 0. Now, why did I put alpha between negative 3 and plus infinity and not between negative infinity and negative 3? Because remember here, alpha is a root on this interval. Now deduce in terms of alpha the sine of a g of x. We need to find the sine of a g of x in terms of alpha. Try also to work it out. Well, if we just read it from this table, this is g of x, it's negative, it's more negative than it goes to 0. So from negative infinity to alpha, we can see that g of x is negative, and then from alpha to plus infinity, somewhere here we can see that g of x is positive. It's just a matter of numbers. While numbers from 0 to plus infinity are always positive, and numbers from negative 2 to negative 2.20 are always negative. So how do we express these ideas? We just put a small table here. X varies from negative infinity to positive infinity, and we put the value where the function g of x vanishes, which is alpha. So from negative infinity to alpha, g of x is negative, and from alpha to plus infinity, g of x is positive. Now why? Remember to put the reason. It's negative because its maximum here is less than 0, and it's positive because its minimum is greater than 0. And don't also forget to put this 0. Now part 4, determine the limits of f of x at plus infinity and at minus infinity. Try also to do it alone. As you see so far, we've seen only g, but the main function is going to be f. So what is the limit at plus infinity of such a quantity? If we just take x squared in common, we get plus infinity here, minus infinity here, and their product is negative infinity. Now, what is the limit at negative infinity? If we continue here, we get this is positive infinity, and e2 minus infinity is 0. So this is 1. So positive infinity times 1 is positive infinity. This one is found by substitution. Part 5, prove that f prime of x is minus x into g of x. Try also to find this relation alone. Well, this is f of x. The derivative of x squared is 2x minus, this is a minus, and the second part is of the form u times v. So we apply u prime v plus v prime u. And if we just simplify it a little bit, we get this expression. And the question is to prove that f prime of x is minus x into g of x. So if we take x in common here, we get this expression, and if we take a minus in common, we get such an expression, which is minus x into g of x. You see, the expression here between brackets is the same as g of x. Now part 6, set up the table of variations of the function f. Try to set up the table of variations. F prime of x is minus x into g of x, so there would be a relation between f prime and g. Let's see the sign table of f prime of x using g of x and negative x. This is the table. This is minus infinity. Well, one of the roots is 0. This is the root for x, and the other root is alpha. And remember, alpha is greater than 0. So this would be alpha, and this is plus infinity. Now for the first row, this is a 0. We apply opposite same. And for the second row, we use the results from part 3. This is 0. Before alpha, it's negative. And after alpha, it's positive. And here we have to put the product. This is negative. This is 0, this is positive, this is 0, and this is negative. So this is the sign of f prime of x. Now we continue drawing the table of variations of f. X varies from minus infinity to plus infinity. We have two values which are 0 and alpha. We take them from this table. Now this is 0, this is another 0. We have minus, plus, minus. Now, minus means that the function decreases, then it increases, then it decreases. The limit at minus infinity, this is the limit at minus infinity, is plus infinity. And then When x is 0, f of 0, if we just replace it here, we get 0. And here we get f of alpha, leave it as f of alpha from this limit. When x tends to plus infinity, f of x tends to negative infinity. So here we have to put a negative infinity. The last part asks to prove that the maximum of f on 0 plus infinity, its maximum is somewhere here, is alpha cubed over alpha plus 2. So in other words, we are asked to prove that f of alpha is alpha cubed over alpha plus 2. Try also to do it alone. Let's begin. First, go back to the main definition of alpha. What is alpha? Well, alpha is a root of the equation g of x equals 0. So we can say from here that g of alpha is 0. Now, what is g of alpha? This means that alpha plus 2 into e to the power alpha minus 4 minus 2 is 0. And we try here to isolate e to the power alpha. So we get e to the power alpha minus 4 is 2. This negative 2 becomes a 2 if we just take it to the right side of the equal sign. And then when we divide by alpha plus 2, this is what we get. Now remember, we don't need the g of alpha, we need f of alpha. The question asks about f of alpha. So we go back to here. What is f of alpha? It's alpha squared minus alpha squared into e to the power alpha minus 4. And then we replace e to the power alpha minus 4 by its previous value. We get alpha squared minus alpha squared times this quantity, and if we take alpha squared in common, we get 1 minus 2 over alpha plus 2, and by simple calculation, we get this answer. So this is the whole story of this problem. Thank you.